Hello, my name is Niall, and this is Open Woods. Today, I just wanted to share with you the research that I've conducted into optimizing open source large language models. So, just a quick TLDR. This is just going to be looking at modern open source language models and how they're shifting from dense to a mixture of expert architectures. So, essentially, I'm going to try and share with you quick little tips and tricks on how you can speed up and make your open source models that you run locally at home a little more efficient and effective, and just kind of going into the core concepts of how that actually works. Next, hopefully by the end of this video, you should have an idea of how you can run more, efficient open source models on your computer. And we'll just be looking at quantization and KV caching. Hopefully by the end, you should be able to handle extreme context handling and just speed up and have near instant responses. Okay, so first thing first, what are the two types of primary large language models that we have access to? Well, obviously, the first set is open source software, and that's going to be the likes of your Llama, it's going to be the likes of your LLM Studio, and these are going to be softwares that we're running open source models like Qwen, DeepSeek, and Gemma 4. Next, we have proprietary software, a word I can not say very efficiently. And essentially, these are, private LLMs which are owned by a company where profit drives decision and where the keys to the kingdom are gate-kept through subscription licenses. So it goes without saying, that's something we're all very familiar with. We pay for access to a set of servers, we input our prompt, that server runs our prompt and calculates what it wants, and then an output is fed, and we pay for that process. Whereas with open source, we download the model and we run it off our own computer. Okay, so why even bother? Why run your own model on your own computer? Well, open source models are available for anyone to access for any purpose, modifications, and for distribution. And in short, you own the model and it runs directly on your hardware. Benefits include cost savings from avoided subscription licenses, privacy by keeping your data local, and custom fine tuning of pre trained models. So, again, you own the model, it's on your computer, it saves you money, and everything is private. So if you're an individual and you value privacy and you don't want these large corporations having access to, your inputs, your prompts, information about you in general, then this is a good reason to run these on your computer. And then secondly, if you are, let's say, a private company or a business and you're kind of wanting to build in-house software, I don't know, just thinking off the top of my head, let's say medical physics, you're wanting to create some medical database or something for, I don't know, a private clinic, then, and you want to implement AI into your system without compromising confidentiality, then an open source model and a system may be the way to go. So MOE, mixture of experts. So in 2026, most, if not all, models are using MOE. And essentially, it is, instead of running every parameter and every step, a learned routine mechanism sparsely selects which subnetworks should participate, allowing the model to grow capacity without paying the full compute cost. So what does that mean? So essentially, what they've done is kind of how our brain works. So you think about, you've got the different parts of the brain, you've got the cerebellum at the back, the prefrontal cortex, the temporal lobes, the camphum, go on, go on, go on. And each part of the brain has its own specific niche, its own specific need. So whenever you have a thought or you need to enact a motor skill, a single part of the brain fires instead of the whole. So essentially, it's mimicking that process. An input goes in and it's fed through a mixture of experts, and whatever expert is needed to perform that task, that's activated. And essentially that creates a faster, more efficient output. Pretty cool. So quantization. Obviously, these are going to be large models. Larger the model and larger the gigabyte size, the more obviously effective and intelligent the model is. But however, not everyone has access to beefy GPUs or servers. So how I like to think about this is, because it's a concept we're all already familiar with. So if you imagine you want to send a image that's 100 megabytes and you want to send it via email, unfortunately, you can't do that because there's a bottleneck. So we convert that PNG into JPEG, and that compresses the image to 2 megabytes, and then we're able to send that on. So that exact same concept is the same with large language model quantization. Essentially, we're using KV caching so we can squeeze that information onto smaller GPUs. So by default, they are stored in high precision. So whenever you see FP16 or 16-bit, you want to be thinking that's a high volume, high optimized, or sorry, a high quantized model. And then whenever you're applying 8-bit and 4-bit, you're essentially compressing those models into smaller chunks, allowing you to run those on lesser powerful GPUs. Okay, so this is just a quick table illustrating what I was just talking about. Obviously, we got our context length, it increases. We've got our model here. Then we have our KV cache, so we're running FP16, so this is going to be, I guess, 100% compression. And then through KV caching, we're running FP8, and we're just dropping that model by half. And then the same when we move to 4-bit, we're dropping the FP8 by half. Again, allowing us to run the same model, but on a weaker computer. Okay, thank you very much for watching. I hope this was informative. I wanted to kind of keep this bite-sized as possible, without kind of getting into too heavy jargon or too heavy information. I actually really enjoyed making this video. It's kind of the first of a series, so I'm going to make a couple of these and just kind of direct them onto open source models. If you like the support channel, I'm going to set a goal of 1,000 subscribers. We'll see how we get on, and leave a comment if you enjoyed this type of video. In the description, I'm going to leave links to the references and the sources where I got this information from, and just some further reading if you want to dive a little bit deeper. Again, links are in the description. Thank you very much for watching.